All right, recording has started. So that's a plan. So a little bit of a overview again. Back to the process model, right? What is it that we're doing today, and where is it in the process, and what does it do, and how important is it? Beginning next week, we'll start talking about modeling. So the modeling is the coolest part of data mining process. It's something that probably got you hooked up with this course in the first place, but you finally get to see it. Before that, there's a little bit of preparations in terms of transformations and things, and not so much cleaning, because we did cleaning in the first homework, right? And missing values analysis and so forth. And then the model stage. So today is understanding and a little bit of preparation. And modeling, and following the modeling, you get the results. You need to evaluate and compare different models on different criteria. Also, some problems involve decision making. So, how to prioritize the decisions and the profit and decision consequences is another aspect of it. But all of these depend on that you have good understanding about the data. So that's what we're going to do today. EDA stands for Exploratory Data Analysis. By the way, let me give you a set of simple tests. Just talk aloud. What is let's see. What is a field? I've been talking about a field. What is a field?
Like in a professional world?
No, in data analysis.
Oh, a column is an Excel.
A column of data. What else does it mean? I mean, the same thing with column. Sometimes we call it a column. Sometimes we call it a field. What else do we call it? Variable.
Attribute. That's a specific value of an
Attribute. Yeah.
Yeah,
Characteristic. Great. What else? So one more I'm looking for, but fairly commonly mentioned. So we have column, field, attribute, and variable. Characteristic. Yeah. It's one more. Feature. Yeah. So these are synonyms to variable. But when we say characteristics, features, not variable, but characteristics, features, we typically mean the independent variable or the input variable, not the target variable, right? And when we say decision, when we say outcome, we typically refer to the target variable or dependent variable in the regression case. So, great, you did well. Great. Let's see. What else? Input, observation. What is an association here? What is this association? What do we call it in other ways?
correlation.
Relation? Correlation?
A strong correlation or a very weak correlation.
Correlation. Great. I think you mean the same thing, right? Relation. Correlation. Yes. Association. Association and correlation, yeah. I think that's it. or covariance sometimes, but that's slightly different statistic, but describing the same thing, the same concept. So what is correlation? Can somebody give me a precise definition in your own dictionary?
A relationship between two variables or two fields.
How do you mean relationship?
How closely they are tied to each other or affected by each other.
I think affected is a better word. How one will influence the other.
Interesting.
How similar they are would be mine, because like the popular saying, correlation is not causation. So it might not be influence, but it's relation.
Good point. Good point. That complements each other.
How one would change if, how X would change if Y would change.
I think that's a very intuitive definition. How the value of one variable would change given some change in the other variable. Right? In the extreme case, if one variable doesn't change at all, given whatever changes in the other variable, in that case, we would say the correlation is 0. There's no correlation. Yeah. If variable A increases, as soon as variable B increases, then the correlation is positive, at least. It doesn't have to be 1. Yeah. If variable A decreases when variable B increases, the correlation is negative. Right? The range of the correlation coefficient is
Minus 1.
minus 1, positive 1. Great. Yeah, that's all I wanted. So with that basic understanding, we can start talking about the concepts for today. A lot of it is based on correlation, right? But sometimes it does have the causation connotation in it, the underlying. But correlation doesn't have to be causation. Can you give an example of when there's strong correlation, but it's not causation? What is causation in the first place? Brian?
Sorry. You said what is
Ta-
causation?
What is causation?
A happened because of B.
B causes A
Causes A.
to change. Yeah? Do you agree? We're all on the same page? Right? Yeah. So correlation doesn't have to be causation, but sometimes it is. But even with causation, it sometimes doesn't get reflected in correlation. Let's talk about the two, one at a time. Correlation doesn't have to be because of causation. Can you give me an example? I think whatever you can think of, they can make a story. It's going to be interesting.
There's I read one, sales in ice cream are correlated to drownings, but in reality it's because it's summer, so more people eat ice cream, more people swim. Like.
You hear that? That's beautiful. Yeah. And yeah, following that same logic, you can think of a lot of things,
Websites.
right?
A lot of those
Yeah. So so if we're on the same page, that's great. Yeah, summer causes the two to co-change. It doesn't have to be one causes the other to change, but it's easy to discern it, but it's not easy to see that in the first place, right? In the world of analytics, it's very important to understand the differences between them. On the other side, causation doesn't get reflected in correlation all the time. Why? So if A causes B to change, why does the correlation don't why isn't the correlation observed?
It's hard to see the trend. Like this, like to me, there's a lot of factor that goes into causation, which
Yeah.
can be overlooked.
So you mean, other than A being the cause, B of B, C could also be another cause, and D could be another cause. So merely looking at A and B, you don't necessarily see the correlation.
Right.
That's very complex. That's very intense. It's hard to say clearly, but I see what you're saying. It makes sense to me.
I have a really
Baru?
funny example of that.
Yeah.
So, if you go through the history, the murder / assassination of Archduke Ferdinand in 1918 is the reason there's so many comic books in America today.
What is the event then?
So, it was assassination of Archduke Ferdinand, which caused World War I, World War II,
Okay.
that caused to America invading Japan, and then they bought the Japanese comic books back with them over here,
Right.
which led to their popularity over here, which is why there's so many comic books in the 1960s, 70s, and 80s.
Mhm.
So it's so far apart, you don't see how that's correlated, but that's an actual cause.
And it's hard to quantify.
Yeah.
It's hard to make a construct a data set.
Yeah.
But I guess that's a one event
Yeah.
and one outcome, at a high level. So yeah, it's sort of I know. That's a good that's a good explanation of why. Why not? Who else want to say something here? So why does causation not always get reflected in correlation? So in other words, A causes B to change. For sure, we know that. But when we correlate A and B, the correlation is 0. Why? So I'll draw a graph. You will see immediately why. Why not? Can you see it? What number did I write? 5. Oh, you can see it? Okay, great. Just a simple test. So, but this is green, it's hard to see. So I just draw a 2 axes. Probably you already know what I'm going to do. So I have A and B, right? A causes B to change. So when A is 0, B is 0. A gets to some point where B is maximum, and then as A continues to grow, B drops. So you can think of a million of examples that it can be described in that relationship. Like satisfaction as affected by food intake. If you're hungry, you get happier as much as you eat. But if you're full, if I force you to continue to eat, then your satisfaction will drop. So that's a clear causation. If you do a correlation analysis, it's 0. Because what? Because something about that, but that's not the language to say that. Because the relationship or the causal effect between A and B is nonlinear, and it's a curve. It's a well, if we simplify it, it's like that. It's a concave shape. It's a polynomial to the second degree. But correlation is a linear relationship, right? So if you use a linear, if you use a mentality of a linear correlation to look at a curvilinear causal effect, you are going to see nothing or close to nothing, because that's not the right mentality to look at it. So, that's the difference between linear relationship and nonlinear relationship. And that's actually a difficulty where regression models cannot work very well. It works somehow, but it doesn't, it gets competed away by machine learning models, because regression model, as good and as classic they are not very equipped to handle nonlinear relationships or nonlinear causal effects. So you can do that, you can add more polynomial terms, but that adds up to the complexity. That's still under a very structural mindset about the relationship. So, and that's when regression model becomes, competed away. So as you learn other models here, you learn decision trees, you learn neural networks. That's how, you can see that you have a better platform to tackle nonlinear relationships. Any questions about what I just said? About the correlation and all of those? Yeah?
Professor, you're mentioning how, I think you're saying regression specifically it has trouble plotting kind of polynomial relationships. Is that because of overfitting, or is there a specific reason why?
That's related. Let's see. How would a regression model try to capture this curvilinear relationship? You add a second degree term. You add a polynomial term, right? For a causal effect as perfect as this one, regression works. But in real world, it's not that perfect, right? The shape of the curve doesn't fit very well with the polynomial terms, whatever you include. So those polynomial terms are confined in some space. You have to follow that rule to add in, and you can add in as much as you want. Then that's a point. There's a point where you go to the overfitting region, and that's how regression also stops working well. So that's related, but that's not the whole story. Yeah. But it's getting too complex. Let's stop there. I don't want to make it too confusing for you, but later you'll see what I'm saying. All right, we're ready to move on. Great. Yeah. So anyway, whatever linear relationship, nonlinear relationship, we're still talking about relationships, right? Sometimes we try to convey or try to discover the causal effects, causal relationships here, but data scientist is not a natural scientist. Data science or data analytics in general, we don't try to tackle scientific questions. We don't try to find the cause. It would be very hard for you to try to find the cause because you are limited in terms of data set. You can't run experiments, can you? No, you cannot. Amazon gives you a huge data set. You go ahead and work on it and increase the prediction performance by 1%. I'll give you $10 million. And so, what do you want to do? Do you try to improve the predicted model by simply try to improve the algorithm, try to improve the efficiency, and try to reduce the error margin by 1% and get the 10 million? Or do you want to recruit a group of customers? I don't know what's happening. Yeah. Well, I have to. It's frozen. Well. Yeah, I do see a exclamation, but okay. So something is not working here, clearly. So there's a connection issue. It's a connection issue between the control panel and the projector. So let me shut it down and restart it, then try to see. Yeah, it's moving. It's good news for me. But anyway, anyway, we lost on time there. The purpose is not to find the causal factor. The purpose is trying to improve predictive performances, right? And also in the process, try to understand the business problem a little bit better. But that doesn't guarantee you that you will find a causal effect. But it helps with the predictive performance objective. Okay, what can I do? Right. So in short, I'm not going to be talking about causal effect too much, and the whole data mining, trying to find a pattern between input variable and the target variable, is trying to capture the pattern, and the pattern is the relationships, associations between inputs and target, although it may not be linear, right? That's why we need the fancy models. So that's the mentality. That's why I talk about association very much. And the visualizations are centered around associations. We try to use graphs, visualizations, points, histograms, whatever, those tools to try to understand relationships between a few variables at a time. Because we're humans. We can't take 10 variables at a time and do a 10-dimensional space exploration. Just kill me. I can't do that, and don't try to do that. And there's no software for that. But at least, from a few variables, you start with a few variables and move on to different variables. You can find those variables that are more important than the others, right, based on those dimensions. And then that gives you some pointers as to how to construct the model as in the later stages. So the slides is talking about hypothesis testing. So in business, sometimes it works, sometimes it helps. You, especially in marketing, sometimes you try to diagnose a failed product. So you start asking why. Why does it fail? Why does the market not respond to the product, right? So then you need to do some customer segmentation analysis, customer profile analysis, and demand analysis, and some market level analysis. So all of those, about all of those effects, if you have data, you can test. And there are statistical testing tool you can test whether or not that's really what you think. So in those spaces, you can use. It's moving, but I'm not sure it will work. I'm not sure. If it doesn't work, it's not going to work for this class, for today, because I depend on that. Typically not, because 6 o'clock. Yeah, I still see the exclamation. Hopefully, no, I'm so let me close this one. Great. Oh, yay. Bless the IT department. Okay, right. So hypothesis testing, I was saying, it's a tool that we'll talk about in later chapters. It follows a specific script, right? But hypothesis testing helps you better understand the phenomenon, what's going on, and try to find, or helps you if you try to find the causal factor there. But as I said, it's not a key mission for data analysts. I think it's a job for managers. Try to confirm those hypotheses, and those hypotheses, they tend to be significant. They affect the marketing strategy, they affect the production strategy. So they are still important, but it's not so much here as we talk about the very bottom level prediction modeling. So anyway, so EDA is good for getting to know the data set, to delve into the data set, to examine relationships, to allow important variables to surface at the very early stage, and also for you to discover problems with the data set, right? Right. So this is the data set as you're familiar, right? Everybody has completed homework 1, right? Everybody has completed homework 1. Great. This data set has 3,000 rows. It's about customers' churning behavior and a bunch of input variables about their accounts. And this is a list of variables. So we're going to focus on that totally today. All right, we need to set up the SAS environment. You probably already have, so you don't have to do it again, but if you want to do it again, feel free. So you will use this data set to finish several homeworks, I believe, at least 3 or 4, but beyond could be. So you can recycle the same project in SAS EM. So what I do here is not necessarily overlapping with what you will do in later homeworks, right? If you want to keep your homework environment clean, you can set that apart. You can create a new project here, or create a new diagram to follow me in the class, and they will not cross-contaminate each other. So yeah, actually, you don't have to create a new project. You can create a new diagram and use the same data set. Yeah. So let's set up the environment. Where is my... here. So I'm going to create a new project. So yeah. Right. Okay, I need to do the library. I need to do the data source. So you know the drill. Okay. I want to make sure that your data source is set up in the same way as I do. If you are starting over, you can simply follow and make sure we're doing the same thing. Wait, here I'm starting to mess around with the advanced. So customize. If you do from fresh, make sure you do the same. Wait, I'm going to change 30. I'll explain why. 10 and 100. So what I'm doing here, this is the step right before I customize the rows and levels of the variables, right? If I didn't do this, if I chose basic and I go next, the next page would be a list of variables for me to change the levels and rows, right? So this step is going to directly affect what is specified in the next page by SAS, right? So SAS try to do some guessing game for you and try to lower the workload for you. That's why you didn't have to change a lot of things, right, on a page of variables, but sometimes you still need to change. Like for target, you have to make sure there's only one target and one and only one target. You need to make sure that the phone number has a appropriate role, right? The phone number in the first homework, what happened to the phone number? Yeah. What if you include as the input? What happens? What will happen? You probably don't know, but if you don't know, that's fine. But if you knew, let everybody know. If you included phone number as an input, that means the model will try to evaluate phone number as an input, assuming that the information about the phone numbers, the digits, has some information in telling whether or not the customer will churn. Do you think that will happen? Your phone number tells me who you are, how you're going to behave, and your fate.
The area code can.
Huh?
The area code may be good.
The area code, yes. Here, the phone number and area code is separate. So we have the area code and have the phone number without the area code. Yes. It's a good point. Yeah. Without the area code, what do you think?
So if it's just a phone.
So it can be considered as a random number.
So should we have rejected that in the homework? That would have been the right answer.
Well, let's see. So there are two approaches. You can set it as ID, and it's good for an ID column because phone number is unique for every customer, and and we typically need an ID. So instead of creating a new ID, we simply use the phone number. Or that's the other way. You reject the phone number, you create an ID, or leave ID blank. Else. But if you had included phone number as an input, then it's a large number. If it's numeric, it's a large number. So it's millions, right? 7 digits, it's millions. So it's a lot of computing load for the computer. Resources used on useless information, so that's waste of resource. If in some cases the phone number as an input had a row of nominal, then you're thrown an error. You have reached the maximum number of levels. The level is 512, and then you get confused. So anyway, the best practice here is to set the phone number as ID. Here, I changed the first threshold. It tells SAS to examine each of the variable, right? And if SAS found over 30% rows as missing, SAS will automatically reject the variable. So this is the threshold I can change. You know, and you need to decide what level of missing you can tolerate, right? If you can tolerate higher, you set it higher. You set it 70%. You know, anything below 70% missing values, you can still tolerate. But you need to know the level that you can tolerate. Here, I'm making 30, so that's 30%, right? If SAS found over 30% missing in one column, this variable will be rejected automatically. So that's what it does. Class level count threshold. Can you guess what it does? So in empirical data, right? If the column is numbers, say 1, 2, 3, 4, 5, 6, 7, think about age, right? 18, 19, 20, 23, 55, 68, 47. I'm making up numbers. What does this do? What do you think? So I still have to tell SAS if the number, the column, is interval or nominal. I have to tell SAS, and you have to make it right? For age, what do you think? It should be nominal or it should be interval? Think twice. Yeah, interval. Age, because the scale is it's continuous. And for SAS, it doesn't matter. But for SAS, what it means is that there are typically more than 10 unique values in interval variables, right? Think of age. How many possibilities can you have? Maybe 60 at least, from 18 to 78. That's 60 possibilities. But it can be more than that. But let's think about gender. What level do you think gender should be? Yeah, two or three. But level, the type, it's nominal, right? It's class, it's nominal. It's nominal because it only has 2 or 3 levels. So that's what this threshold does. For any variable that has more than 10 unique levels in the values, assuming it's numeric. If it's string, it's automatically class. But if it's numeric, it may be vague, right, for SAS. So this number tells SAS that if SAS detected more than 10 or more than 10 unique values, it's automatically interval. That makes sense, right? If it's below 10, it's automatically class. And you will have to think about this data set particularly. Does it make sense, right? If it's a different data set, you might have to change it to 15, because you might have a class variable that has 12 levels, and you still want it to be class variable. That make sense? Mm-hmm.
So that's how you decide, by looking at your data first and checking?
Yeah, it kind of requires some knowledge about the data set. But other things, the common sense, right? So that's the second number. The third number, try to take a guess. What does it do?
If it has X number of levels, it'll be eliminated or rejected?
Mm-hmm. Can you think about an example? Do you remember what was the value before? I think it was 10? 20. Oh, yeah, it says default value of 20. Yeah. So, think about for state. How many levels do state have? Typically. 50, right? 51. 50 or 51. Can you imagine that if we left this number at 20 and we go forward, what will happen to the state variable? It will be rejected. So that's why I increased it to 100 so that state will not be rejected, right? So are we all clear on this page? So this is not super critical. It's helpful, right? It's helpful if you have a large data set. If you have 1,000 variables, God, how far you can imagine. If you only have 20 variables, you can always change one by one, right? So let's take a look. Phone number is rejected automatically. It wasn't if I hadn't done the advanced step. Why? Yes, exactly. First, it has to be nominal first, and then the number of levels exceeded 100. Yeah, so it's automatically rejected. So that means what we changed has taken effect. But here, I wanted to do ID, so I simply changed that. So I'm not criticizing SAS. SAS is helpful, but I want to do something different. That's basically it. And there's another thing we have to change. SAS didn't guess which one is target, but there wasn't any information for SAS to guess, right? So it couldn't, it's not a good expectation. So you need to go ahead and intervene and change that to target. Churn. What else? Everything looks good. Area code nominal. Let me change it to interval for now. Let's see. That should be good. So make sure you have the same settings as I do. You need more minute? No? We're good? Great. So decisions, we're not going to do decisions now. And straight through, yes, and finish. All right. Now I'll create my first diagram. All right. Drag the data source.
Once we finish the first 8 steps, we've completed on that flowchart, we've completed the preparation phase?
Not yet.
Oh,
Not yet. That's only for data source. Yeah. So data preparations data preparation includes generating graphs, visualizations, or analysis, descriptive analysis of the data set. So we haven't even started the visualization yet. So everything we do today is the preparation and as well as understanding. Okay. Now, before I do the stat explore, let's see. Let me go back to slides first. All right, good. So this is a snapshot of the data set. It's taken from the spreadsheet. And, those are the typical format of the different variables. We have a phone number is in string type. So there's a dash inside. So that's strings. So they can't be numbers. It can't be numeric. And international plan is very likely to be binary, as well as VMail plan. All the minutes, calls, and charge variables, there are 4 types, seem to be numeric, and there are decimals. There are day, evening, night, and international. There is a customer service calls, number of customer service calls, seem to be also numeric, but with small numbers. There's a state variable that has state abbreviated there. Begin demo in SAS EM. It's there's a commander there that's giving me orders. Anyway, so we kind of took a look at the data set already. Let's try to find these insights. The variable phone uses only 7 digits. So we saw that in the previous slide, but is that true in the data set? How do you find out? Right? How do you find out in SAS? There are 2 flag variables. That's kind of SAS casted in the variable page. Most of the variables are continuous that we already know. The target variable is a binary that has 2 values, true and false. We can also find out churn. The meaning of churn is that they left the company. And just to be sure, everything inside this data set describe the information and the behavior of those customers in the past, right? You can understand as of current or up till today. These customers have made these decisions. These are histories, right? These are what already happened. It's not something that's going to happen, or it's not something that's unsure. These are for sure. Okay, how to find out the values of the phone? Let me do this. Okay. Yeah, how? How do you see the values? Imported data. Very good. That's where that's the best place. It's not there. You need to run it. Yeah, now it's there. You can browse. Or you can browse the data set. Then you have the phone number. Yeah, it's 7 digits with a dash inside.
What is the data type?
The type. Okay, it's a little bit technical. The level is nominal. Yeah, because every value is unique, right? Phone number is unique. The exact type in the storage, I guess it's strings, characters. But you can still sort, right? Based on these. String is character value.
String, right?
Yeah.
string.
Yeah. So this is where you can look at the data set, and in every node, almost every node, you can access the imported and exported data set. You'll see the same view, but not the same view, but you'll see the updated data set at that point, right? Because imagine a data set is passing through the process, but changes are being made to the data set. All right, so we confirmed that. Now, getting to know the data set a little bit. There's one tool, there's one node that I said is very, very useful. That you can use that tool to quickly see the distributions of every variable in the data set. What is it? Transform variables. Yeah, you'll be very clear on that because that saves you a lot of time. and plus that node can do other things. So that's what we're going to do here. We'll quickly take a look at the distributions, as if we're doing something like this. You can see the distribution right away for all the variables. Right, where is transform variable? It's under modify because it's making changes to the data set. And the nifty tool of transform variable is within the formula. Before you do that, it will ask you to update the path. So might as well just do that. So now under the train, there's a formula. We go into it. Wait, yeah. So let me talk about something here. This is where you can quickly browse the distribution for all the variables, right? You go from top to down. It's very fast. It's almost instant. Even if it's a large data set, it's going to be instant. I want to show you something here. It's quick. It's fast. You might think it doesn't allow many customizations, but you can still customize the graphs. So let me show you something. We have a customer service calls, right? It's typically 0, 1, 2, 3. So you can see the range is between 0 to 9. But you have a bar which is between 0 and 0.9, and a bar between 0.9 and 1.8. It's kind of weird. Number of service calls is typically integers. There's no decimals involved. But it just made it that way because there are only 9 levels or 10 levels, but 9 bars are being made or something like that. So we can change that to make it better for reporting purposes. So what you can do is you can right click graph properties is to change how the graph is rendered. There is a bin tab, which is already highlighted. Horizontal bins, we only have horizontal bins now. It turns out that there are 9 levels, not 10, but 10 was being used, which breaks the integers into decimals. So if you use 9, and do apply, what do you see? So those tick marks are, aligned and well and looking very good. So that's a trick you can do. But see this. So I'm on customer service. I go up. I go down. It goes back. So just know that everything you do here is not saved. Okay, there's one thing I forgot to do, which happens a lot. You started doing something and you realize something you didn't do, and you have to go back. The graphs that the transform variable made is based on a sample. So think in the shoes of SAS. SAS couldn't assume. It can't assume every data set is reasonable size. Sometimes the data set is like trillions of records, and it doesn't assume that your computer can handle every data in memory on the fly. So it automatically takes a random sample of any data set and do graphs based on that smaller sample. But that's good, just to be prepared. right? You don't want users to forget to do that, but then the software hand trying to make some graph of the entire data set. That's not good for SAS and for the user. But here we have a smaller data set. So we want to use the entire data set. That's almost true, always true for the entire course, right? So hopefully you form this habit. Whenever you do the exploratory tools, always take the entire sample. But there's something you need to change for the transform variable. Here in the sample properties, change it to max. Change it to random, and then modify the size to be max. So that assures that every time it takes the entire sample. And you need to update the path before you go into the formula again, right? Great. And let's see. Going to the formulas. Explain interactions. Okay, great. Question?
What's the difference between updating and running?
Yeah, updating. At least I'm not super very clear on answering that question fully, but at least I'm sure that updating will transfer the data over to this node, but running will do everything that you tell the node to do. So updating is typically faster than running, to finish. But if you do update, it doesn't do everything, at least. Let's see. Do we need to run? Go to formula explorer. I think we're fine. Okay. There are several other tools here under Twain. There's interactions here. So I'll briefly explain what it is. Interactions is for you to create interaction terms. If you know about regression, then you know that you can multiply some variables together to make a new variable, right? And that is sort of introducing an interaction term. So this is where you do it. You can go to interactions, and you can, let's see, I want to make a term, or I want to make a new variable, but that new variable is based on two existing variables, right? It's account length times customer service calls. So I will drag those two variables over and save, and then it makes a product variable between the two variables, right? You can check the values. I'm sure they are correct. So if you do that, and now you have to run because you're making some significant change to the data set. And after you run it, you take a look at the exported data set. You will see the new column is the product between the two variables I just did. So that is good, but I'm going to delete that. I don't want to do that. I'm just illustrating. And one more thing. So there is a very cool function here. Actually, it's there in every node, but we don't use it. There's a SAS code node, which gives you more control on what do you want to do about the data set. This is the window to SAS programming. Right? If you want to program, then you go through the SAS node. So has anybody had any SAS programming experience? Oh, you do?
Yeah, I learned it a little bit online. I just watched some tutorials and learning some.
Yeah. Great. Is that something that your company wants?
Not exactly. I just learned by interesting.
Okay, great. Yeah, so SAS programming has two types of operations. One is data, the other is process. Right? Data is where you change data. Process is where you do some analysis. And the programming language of SAS would be different because you won't see those. I mean, the interface will be different, but as far as coding, it's going to be similar. So in terms of the IDE, the integrated developing environment, you know, the color coding thing, right? As soon as you type, it will change color if you use keyword. Like data is a keyword. Then you create a new data and you can use the library. Your mylib dot is a library terminology. So you create this data and semicolon at the end of line every time. So data creates a new data set. There's always, almost always, you create a new data set based on an existing one. So set is by copying an existing data set. So this is just a show in SAS, basically. It's not something important. And run, then you can run it. These codes don't make sense, but I'm just randomly typing. But the keywords are right. Like if the keywords are right, it will be color coded. So you have this level of control if you know SAS. Transform, and the last one will be that what you do about those variables in terms of transformation, right? You can log transform, you can standardize, right? You can do z-score standardization, as in homework. You can do range standardization, which is min-max standardization. I think that's mostly it. Method random. Yep. Okay. Yeah, I would like to go into the distributions to take a closer look. So we want to take a look at the distributions and to find out those variables that are skewed distributed. You know, those variables that you think is highly skewed, and call their name. Wait, hold on. So this is account length. Is it skewed? Yes? No? Slightly. It's I think it's benign. It's okay. I'll let it go. Area code? What's going on? It's a big gap. We'll leave that alone for now. Churn is binary, so it doesn't make sense for skewness. Customer service calls, what do you think? Just call its name. Just, customer service call is skewed.
Right skewed?
Right skewed, yeah. Even better, much better. Yeah. Okay, day cause. It's the cause that happened in the day. Left skew slightly. It's fine. It's okay. It's okay. Yeah. So, you see what I'm doing? So I'm switching back and forth between day charge and day min. What do you notice? Value changed, yeah.
But the graph is the same.
Distribution is the same. Are you sure it's exactly the same?
No, it's not exactly.
Oh, wait, other than the ranges? The shape? It's the same. Why?
Because you get charged for the number of minutes you talk.
Say that again?
You get charged for the number of calls you make, because day calls is like the length of your call or how long you're talking, and day charge is what you're you're getting charged for that. So if you're calling for a minute, you get charged for a minute. You're calling for 10 minutes, you get charged for 10 minutes.
Does that make sense?
Yes.
They are fully correlated.
Yeah. Yeah. Fully correlated. They are mechanistic relationship. It's mechanical. It's so in other words, you can suspect that the rates are fixed. Does that make sense? The rates are fixed. You know, a charge per minute is fixed, right? So the more calls you make, or the more minutes you use, the more you're charged, and the rate is fixed, right? What about calls? I'm switching between calls and charge. Calls and minutes are not exactly the same, or related, right? Sometimes you make a longer call, sometimes you make a shorter call. People are different. So as I switch in between those, there's some difference between the distributions, right? Oh, let me go on to evening calls. Slightly skewed. Evening charge and evening minutes. Wait, I always hit the touchpad. Let's see. Evening, blush. Evening minutes and evening charge. I'm switching back and forth. It's the same. And night, international minutes and charge. Similar, but not exactly. So you can kind of imagine that there's a little bit more going on here for international plan. It's not a fixed plan, but it kind of changes a little bit depending on how much you use it, right? It's like dynamic rate. You can call it dynamic rates. The more you use it, the per minute charge may drop a little bit to encourage people to use more. That makes sense? That's the marketing, sort of a tactic. The more you buy, the higher discount I give you. The tiered, it's like the tiered rate. International plan, night calls, night charge, and 9 minute, almost identical. And states, across 50 states. Voice message. Great. So I had a question. There's a big bar to the left, and what do you think is going on?
A lot of people just don't have voicemails, or maybe they didn't activate their voicemail box.
Either they don't have voicemails, or
either no one left them voicemails, or they just don't have a voicemail box. They don't have
right. They might not have the service, but the range is between 0 and 5. It doesn't necessarily mean it's 0.
Yeah.
It could be 1 still, right? How do you find out?
Expand the levels.
Yeah, Sean's right. Adjust the bin. I have between 0 and 51. 51 is the maximum. So if I had made 51 bars, then I would clearly see what is the number 0 that is the spike, or is the number 1, or is it multiple numbers, right? So if I make 51 bars, every integer will have its own bar, right? So you know how to change the bins, right? I just showed you in customer service call. You right click and go into the property graph property. You can change it to 51. See? So now it's getting better. So which value do you think is the mode? Yeah. Now it's clear. It's not 2, at least. It's not 1. It's 0. So those people have a value of 0, and they are the majority of the sample, right? And mail plan. Now it's gone. Anyway, so these tools help me answer some questions. and rather important ones, at least, at the very beginning stage of analyzing the problem, analyzing the data. So, one thing, the reason this tool is formula is you can use a formula to create new variables. Because you can create new formula here, and you can, do the simple math. You can do plus, minus. If you want to shift any variable to the right by 5, you can add 5 to that variable and make a new one. So that's why it's called formula. And then they make it so nice that I think the distribution tool is much better than the formula. It kind of take over the purpose. But anyway, you can do that. And there's something we can quickly check here, is to check the rates. So I will create the rate variable, let's say day. How would you do that? Division, right? What divide what by what?
Called by charge?
Call by charge.
I don't know, minutes, but
Yeah. Charge by minute, exactly, right? So charge is the product. So yeah, we can do that. If you remember the variable name, you can simply type. Otherwise, you can select. You can build. I'm going to type as I know. So this variable is day charge divided by day minute, and its name is called day rate. See, that's changed, updated. When I do OK, a new variable is created with the labels and type appropriately set. You can check the formula again to make sure. If I had a typo, that won't go through, I think. So this means it went through. And so this time we have to run it. Results. Now the operation used 2 variables to create a new variable, right? And what do you expect about the rate? It should be all the same value, or very close values, right? So what can I do? Here, I can make some plot and do a histogram with the new, no, bad place, sorry. I need to go to the exported data. Do explore, do the graph, or we can browse it for a moment. The rate is all very close to 0.17. It's not exactly 0.17, but because of rounding, probably. And then I can do a graph of histogram and use the rate as x. You see the values are highly concentrated around 0.17. So that confirms the notion, right? Sometimes you can't get a hold with the company to answer some of your questions, and you can get those answers from the data. The data tells you a lot that sometimes even a company can't tell you. If you know how to work with the data, right? Does that make sense? Can we move on? Good. Yeah, I've already made you sleepy. But anyway, so right, let's move on to the slides. So the skewed distributions that you can find here in the slides has already been confirmed. You have the voicemail message has a spike on the 0 value. all the minutes and charge and calls don't have much of a skew, but the customer service call has a big skew, as well as the international calls. And that's it. So we already demoed in SAS. Okay. In terms of generating plots, transform variable is one tool. It's very quick. You know, you can browse everything very quickly. But one is you can't save the graph. It's only histogram. It's only bar chart or histogram. You can't do scatter chart, right? And you can't make two at the same time. Sometimes you need to make two to compare. Sometimes you need to make two graphs to link, right? Sometimes you need to analyze the subsamples. Based on one condition, you want to look at distribution on the other condition. That's a linked graph, right? So you need another tool. That's Graph Explorer. So similar to Stats Explorer, Stats Explorer gives you stats. Graph Explorer gives you graphs. But before we make those graphs, we need to know the purpose, right? Let's back out a little bit. So what's the purpose of this project?
To know preparing
To prevent who churn. To do that, we need to understand why they churned. We need to build a model that can predict churn for the company, right? And to build a good model, we need to include the relevant variables, right? We need to understand the relationship between the inputs and the target, right? So that's the purpose. And now we can move into the analysis. It starts from the analyzing the churn variable first, right? What is the percentage that they churn? What is the percentage that didn't churn, right? And it turns out that 15% churned, so it's not so bad, I think. So the target is to predict who's going to churn, right? And this target variable is a binary variable. So then start to think about how other variables can be correlated with that. From previous class, we took a look at the voice message, right? Voicemail plan, right? We took a look at the voicemail plan and made some bar graphs and try to see if voicemail plan made a difference in terms of churning. I think I have that slides here. Voicemail plan. International voicemail plan, yeah. Okay. So voicemail plan is a binary variable, and churn is another binary variable, right? So in analyzing their correlations, the Pearson correlation doesn't help very much, because that's useful for interval variables, right? So here we have you have another tool, which is the chi-square correlation. And chi-square correlation is based on a contingency table. Contingency table. You have one variable at one dimension, V male, plan. You have churn. Both of them are binary. You have 1, 0, 1, 0. then you can make a 2 by 2 matrix. So this is what we mean by contingency. Well, you know what it means? Let me just quickly finish that. So the entire sample can be segmented into the 4 cells, right? And based on where the data is distributed, you can construct a statistic which describes the correlation between the 2 variables. And based on visual examination, we can also do that. You know, the conclusion might not be different, but then the visual tool will get you an impression about the conclusion, and the statistic will get you an accurate statistic, chi-square, or sometimes we do that. All right, after the short break, we'll come back and I'll keep talking about the contingency table. Question? Okay. This is let's see. This is because when you convert the CSV file in EG, there's one thing that wasn't selected, and so the variable names were not converted very well. I'll show you where. So this is the process. I went back to it. And the second step, this has to be turned on. So we show you do it every time. So what you need to do now is to go through this process again with this turn on, and then it will prompt you to replace the SAS data set. You will say yes. After that, you will export it again, change the name, and then everything will work. Sure. And but before you do the export, make sure you use the it will lock that. Okay, let's come back and let's finish off for exploratory data analysis. So let me remind you what we discussed last time, right? We're trying to find useful variables to predict churn, right? I think last time we heavily focused on the voice message, right? And we did a series of analysis, and we went through a journey, which finally led us to some kind of better tools. And here I'm going to show you what is that tool, the chart, and how to make it in SAS. Okay. So contingency tables. If you graph it, then this is the graph that you will get. I'll turn off the light in a moment. Let's say, if you have 1,000 customers, and 25% of them have voicemail, and 75% of them don't have it. When the customers have the voicemail, it's you need to take a peek. Yes. Okay. For those who have the voicemail plan, only 250. Only, let's say, 30 of them churn, and the rest of them didn't churn. So this is like 1/8, something like that. Close to 1/8. 1/8 of the column. it's hard to, anyway. And of those who don't have the voicemail, that's 750. That's 750. And 350 churned. 300 didn't churn. This is obviously fake. But to make to illustrate the point. So to analyze the relationship between voicemail plan and churn, you look at the proportion of churn under each condition, right? I'll use this blue color to indicate the column percentage. So 30 out of the column total. The column total is 250. So 30 out of 250 is close to 1/8, but not exactly, but close. And 220 out of the column total is 7/8, right? So under this condition, only a small proportion churned, right? But if you look at this condition, and larger than 50% of them churned, and smaller than 50% didn't churn, because that's larger. So if you switch between the two conditions, the proportion of churn increased dramatically. So that means that, well, if you switch between having the voicemail plan to doesn't have the voicemail plan, the percentage churn increased. That means not having the voicemail plan is correlated with a higher percentage of churn, right? So not having a plan increases the proportion of churn, or makes it easier for people to churn, right? So the takeaway from that, at least, is that having the voicemail plan helps people stay, or it probably provides some value to those who have the voicemail plan, so that the percentage churn reduced. By not having the feature, proportion of churn increased. So maybe it can be, maybe the management considered to introduce to do more advertising, or to do more discount on adding that service to those who don't have it. So that's one lead for you to go. And looking at the numbers and proportions may not help very much for humans, so we can put that into graph to see that. But keep in mind that these graphs don't reflect those numbers. Those are dramatic. This is less dramatic. So this is the sort of the what do you say? So it's a bar graph, color-coded bar graph, to show the correlation between two binary variables. The two bars represent the voicemail plan, right? So those who have the voicemail plan and those who don't have the voicemail plan are separated into two bars. The colors represent the outcome. The red indicates that those churned, and the other color indicates that they didn't churn. First thing to notice is that proportion-wise, those who don't have the voicemail plan has a higher likelihood of churn. So that looks like 1/7 of the group. But with those who have the voicemail plan has a lower likelihood of churn. It's 1 to the 8 or 1 to the 9. So that's slightly smaller percentage of churn if they have the voicemail plan. So the conclusion would be similar, although it's not as dramatic. But even though the two bars are the same length, the count of the cases are not exactly the same. There are quite different. So this is what's called the normalized bar chart, where it extends or normalizes the length of the bar, even though it doesn't. It doesn't mean the total count of data is the same. It equalizes the bar length so that you can clearly see the difference in proportions, right? Otherwise, if you make this bar shorter to reflect the difference, then the bar may extend to only to this point, and then the proportion of red will be shrinked. In that case, you can't compare very well the proportion between the two conditions, right? So the normalized bar help you on that. So let's change. Let's try to make this this graph in SAS. So I'm going to deviate from what I did last semester, just because it went this way. So we're going to make a bar graph grouped by voicemail plan, and try to overlay the two outcome under these bars. So let's see. In SAS, what do you use, right? To make that exact graph, you will use the Graph Explorer. So that's where you customize all the graphs, and you have to make graphs if you need any. But before I talk about that, there's another tool which is great, which is called multi-graph. Right, multi-graph helps you make batch graphs. Batch graphs for a particular purpose. If you want to make a particular kind of graph for every input variable and color-coded for all the outcome, like a churn. So if you want to make a graph and then color-code outcome, then you can make those graphs in batch using the multi-graph. So let's take a look. In Explore, is it Explore? Yeah. Multiplot. Is under Explore. So drag over. There are a few things we have to change. Let's see. Oh, here, the chart type. So before you make a choice, you need to be sure what do you need, right? This is bar chart, and bar chart color coded by outcome, so sort of overlaid bar chart. Another chart is Scatterplot, where you have two axes, and then you have points to indicate the coordinates of each point based on two dimensions. So you need to make a selection here. Is it bar chart or scatter plot? It's bar chart, right? So it makes a bar chart for each input variable and overlaid by the outcome. So that's what it does. And it make them in batch. And there's something else I need to change. No, for the moment, change the bins to 15. I'll explain why. And now we can run it. Doing fine? Great, let's take a look at the results. Look at that. So it's it's a similar chart that you found in the slides, right? It's color-coded by Churn. It's red and blue, and a distribution chart, a bar chart for the main variable. The variable here is account length. So account length by Churn is this sort of the interlaid chart. If you can do slideshow, but it's not necessary. Scroll over the different variables, you get area code, customer service calls, they charge in a lot, but I want to go to the voicemail plan very quickly. Okay, so this is a interrelate bar chart, but not normalized. See what I'm saying? So the chart in the slides is normalized. You have the bars with equal length. But here, the length of the bars represent the number of cases here. So the longer the bar, the more cases you have. And now, try to imagine that you want to analyze a correlation. And then you focus on the proportion of the red bar in the entire bar. Can you really compare?
No.
Because the length is different. You have to do the mental, translation to really get to the proportion first, and then you compare. But it's really hard, right? So with the raw bar, with the raw chart, it's hard to do that. That's the case when you have different frequencies of the two conditions. For some other charts, it may work, like states. So this is the interlaid bar graph of states, right? Interlaid by the outcome. The bars are roughly the same size, so you can kind of see the proportion of Churn is similar across all the states, although there are some differences. For others, it may be useful as well. An international plan. Here, it may be useful because you can kind of figure out this is close to 45%, even with the dramatic difference in the bar length. You can see that the red portion is close to 40 or 45%, and in this longer bar, it's top 20. It can't be more than 20, right? So 20 versus 40, it's still big difference, right? So in these cases, you can figure out even without normalizing the bars. But as I said, it's not always helpful with these, different proportions or similar proportions but different lengths. It's hard to compare. So in the slides, in the textbook, they show the normalized bar chart. Unfortunately, in SAS, we can't make it. So SAS doesn't provide the capability to do that. But there's something else you can use, which is a pie chart. You use pie chart because a pie is normalized by nature, right? So the proportion of a piece of pizza represents the proportion of the entire group. So you can use the slice sides to compare relative proportions. So let's do the pie chart, as well as let's do the same interlaid chart, but in Graph Explorer, right? So what I demonstrated just now is the multiplot, right? In multiplot, it makes this, it makes the graphs in batch. It makes everything for you without you having to specify, and you have everything here. But you can't customize too much here, right? You can't do an interlaid graph between two input variables. You just can't do that because the interlay here is the outcome. So you need more space for customization. To do that, you can use the Graph Explorer. So it's also under Explorer. Graph, the third one, fourth one. Graph Explorer. So, as well as with the transform variables, make sure that you change the sampling method and make sure you get the entire sample. And now you can run it. So it doesn't give you much by default. It gives you a graph of the target variable, so you can see the percentage of true churners is close to 1/6 or 1/7. When you highlight the bar, you have those rows highlighted in the data view, right? If you highlight the other, then the other rows are highlighted. So this is the linked graph. You can explore that feature. It doesn't give you much. It gives you an overview of the different types of variables. But you have the capability of making new graphs as much as you want, right? And the ones that you make can be saved. So this is the advantage over the other graphing tools. So to start making graph, you need to click this button. Sometimes this button is grayed out. So to get that button back, you need to activate one of the graph, at least. So you activate that, you can see that button. If unfortunately you lost all the graph, then there's no way you can get it back. Within the view, you have to exit the view and re-enter the node again. Does that make sense? Yeah. So now you can do that. Let's do a bar chart of a voicemail plan, right? So let's do a bar chart. You can do horizontal, you can do vertical. Your choice. The category is the two bars, right? What are the two bars? It's the voicemail plan. Allow multiple. So this is the stacked or clustered bar chart. I'll talk about that later. So without ticking this, you have no other choice. You will have to replace that one in order to choose a second variable. So for now, we're doing the voicemail plan and customize the title. X label is voicemail plan. Y should be frequency. So there you go. And you can do this. You can minimize it and then reopen it. It will reorganize the windows for you. So I have two graphs and they are internally linked in terms of the observations. Here I have the churn, and down below I have the voicemail plan. So to see the proportion of churners, those who churn, under different conditions of voicemail plan, I can simply click the true condition, right? And then you can see that it seems like those who don't have the voicemail plan has a higher likelihood of churn. Those who have the voicemail plan has lower likelihood of churn. But again, this is not normalized, right? You can only see the exact numbers comparison. You can't compare the relative percentages. So, and it doesn't give you an option to normalize the bar length. So we can't rely on bar charts, and now we have to turn the attention to pie charts. So let me demonstrate how pie chart can be better in this case. So we will make a pie chart. For pie chart, you by default you have to have a category first. The category is typically the outcome, right? It's the condition that separates the two outcomes. So that's the churn. So you want the churn to be the category, but also we want to see two bars. We want to see two pies. The two pies, one for each of the two conditions of the voicemail plan, right? So we need the voicemail plan to be the category, no, the group. And change the title. Chart of churn by B mail plan. Footnote, legend. Churn. Legend is top. Legend. Bottom. Okay, so take a look. So this is stacked pie chart. It's not really two pies. I'm getting only one pie. That's not fair. Anyway, but this makes it easier for you to compare the exact percentages, right? Because they are aligned on one edge. So in the inter circle is those who have the voicemail plan. The outer circle, outer pie, are those who do not have the voicemail plan. You can clearly see which group has a higher likelihood of churn. Which group has a higher likelihood of churn? Yes, with or without voicemail plan? Without, right, the outer circle, the bigger pie. So this sort of replaces the value of normalized bars, and pie charts is kind of cool. So yeah, so you have that, and wait, if you minimize that, it will try to reorganize the windows. And let's see if I will lose the graphs. So I have those graphs, yeah? So they won't be lost. Sometimes it lost. I can't say for sure, so caution. But at least for temporary, you have those.
With diagrams, we can always save, right? Separately.
You can well, what can you save? Copy. Yeah, copy to the clipboard. You can save
or
to.
Go to File and Save As, maybe.
Yeah, it doesn't. You can print.
Oh, right.
So limited.
Yeah,
Limited.
mine says-
You can save.
Mhm.
Are you saving this graph, or are you saving the entire node?
I think I'm saving the entire node as a result. Yeah.
So this. What does it save as? It saves as an output file. Yeah, you can try. Yeah, you can try. I don't know. I don't know for sure if you can, extract it very easily into Word files or Excels, but at least you can save the picture. You can copy that. Yeah. Question?
I have a quick question regarding to the pie chart.
Yeah.
Would it be easier to see if we make two pie charts? Oh wait, no, that would.
If we make two pie charts.
Because you know how it has a relationship.
Yeah. Well, if I click true,
Right.
which part do you think will light up?
The red one.
Yeah, exactly.
Okay.
So you can use your imagination to think about what graphs you want,
Okay.
and you can do multiple, layers if you want. Yeah. Other questions? Great. So I skipped these these slides. I skipped the EM part for these analysis, but you can make them yourself using the same tools. For instance, this is a plain bar chart for the target variable, right? You see two bars, and there's no colors, and it follows by having an interrelate chart of international plan, and interrelate by the outcome. So you have colored bars. The longer bar represents those customers who do not have the international plan. Those with the smaller bar are those who have the international plan, right? So you can see that the likelihood of churn is much higher when they have the international plan, right? The percentage is close to 40%, but it drops in terms of proportion if they don't have the international plan. So somehow international plan is making people leave, in a sense, right? So then the company definitely want to investigate what is wrong with the international plan, or what is wrong with the segment of customers who subscribe to international plan. Are they leavers by definition? So that might create prompts other questions to study. But either way, it leads you to a direction, right? You can follow up with more analysis. And again, this is the normalized chart, but we can't do it in SAS, but we can do the pie chart for the same purpose. And this is the contingency table, and the percentages here represent the proportion of the colors in the bars, right? So you can translate between them. And also, if you switch the variables, you can kind of imagine two versions of color layered chart, right? The bars can be conditions of the input variable, let's say the VMIL plan, right? VMIL plan has two bars. Within each bar, you have churners and non-churners. But you can also do churn as representing two bars. You have churners and non-churners. Within each condition, you have those who have the international plan and those who don't. So different perspective to analyze the correlation, but the conclusion would be the same. I think that's good. Stat Explore. To get the contingency table counts as well as the percentages, you already have the tool. So let me show you. You have Stat Explore, right? You typically use it for missing values and type of variables. But you can also get the contingency table statistics. So if I do Stat Explore and make sure I have all of them, all the observations, make sure I have the interval variables changed to yes, and I can run. The first thing I did is to make sure I have the full sample analyzed. The second thing I did is to make sure that the ranking of the variable worth also includes the interval variables, not only the class variables. Okay. Now the results output you know, as you would expect, it has a list of different types of variables. You have class variables, you have interval variables, and within the class variable, you also have the target, which is a class variable. Then you have the percentage of the different outcomes, which is the same as in the slide. And down below, you have the proportion of churn and non-churn under each condition of the class variable, every class variable. Let's say for state is too much. Voicemail plan. Under the condition of churn equal false, so those who didn't churn, the mode is no. That means there are more customers without the voicemail plan than with the voicemail plan. So within the false condition of churn, more customers do not have the voicemail plan. And the mode percentage is 70%. Right? 70% of this group who didn't churn do not have the voicemail plan. Mode 2 is the other condition with voicemail plan, and 29% of them has the voicemail plan. So they add up to 100%, right? In the row. And the second row is those who churn. Again, more customers did not have the voicemail plan, and less customers have the voicemail plan. But you can see that the percentage of not having the voicemail plan is higher in churn, in those who churn. Right, so you can get to these statistics. Let's see. Right. Okay. I think that's good. Scatterplot. I haven't shown you Scatterplot yet. So Scatterplot is for for examining the correlation between two continuous variables, right? So let's say here, what are the two variables that you would expect to have high correlation? Minutes and charge. And that would be almost linear relation, or I mean perfect linear relation, right? So we can generate some scatter plot to look at the correlations. So the same place, scatter plot, and the first. Okay, we need to select X and Y. Oh, yeah, this is the bad place to be to do the scatter plot. So Stat Explorer is the only place that you can't do exploratory charts using the original variables, because it creates all kinds of stats for you to use, and you can use those stats to plot for different purposes, but not for the purpose that I need. So a better place would be Graph Explorer, but actually any other node other than the Stat Explorer. Let's go into here and scatter plot, and you have the original variables. We need to do the day charge on Y, day minute on the X. Okay, scatter plot, day charge, by day minute. X is day minutes. Y is day charge. Look at that. What does it say?
The more you talk, the more you get charged.
Yeah, and it's perfect linear. It's perfect linear. Yeah. I don't like the size of the tiles. It's too big. But you can change that. You know, under graph properties, it's about the, let's see, graph. No, sorry. Scatter. Auto size markers. If you don't want auto size, you can change it to smaller. And let's see. Much better. Yeah, so it's a linear line of correlation. Okay, let's see. And you know, if you have a lot of interval variables, then you know you need to make pairwise scatter plot. So you need to make a lot, right? Sometimes it helps to make a matrix of scatter plots to kind of see everything, you know, at once. So you can do that here. The type of graph is called matrix plot. And for now, let's just dump everything in it. And you can change the color. You can change the color of the dots by conditions. So let's do that. So it will color code by different churn outcome. Look at that. But this is kind of too much, a little bit too much. But at least you know. What do you spot? You know, these graphs are those perfect linear correlations, right? And it's diagonal-wise, you know, mirrored, right? So it's equivalent across the diagonal line. For a lot of these, you know, usage variables like day charge, day cause, if they are not perfectly linear, like between day minutes and 9 minutes, what do you see? It's kind of random. You know, there's no clear lines there. There's no clear correlations over there. That just tells me that this data set is partially fake. It's a toy data set by nature. It's a toy data set. It does reflect part of the world, but it doesn't represent the real sort of, you know, the business cases behind. But it, you know, it helps for you to learn exploratory tools and also data mining. There are some correlations there, but not a lot. For normal customer, what would you expect? If you make a lot of calls in a day, what about night? You may also make more calls at night. Typically, but it's not hard to imagine for a segment of the customers who make most of the calls at night, but not in the day, because typically with the telecommunication plans, night minutes are free, but that is 10 years ago. So 10 years ago, night minutes are free. Day minutes count as part of the quota. So a month, over a month, you have 600 minutes for the day. So once you hit that limit, you'll have to pay for additional, or you have to upgrade the plan, which means more money. But night minutes are free, complimentary, because the demand is lower at night. So it's kind of a benefit of the plan. As versus if you buy a per pay phone, then you have to pay every minute, day and night, right? So that's part of the benefits of having the plan. That was more than 10 years ago. Now the calls are all free, right? Texts are free, calls are free. Data is close to free, but not yet. We're getting there. But it's getting cheaper because of internet, right? Question?
Can you go back to that enterprise miner diagram again?
Yeah.
So on that, are there certain tabs, like you made a comment that you cannot plot after you use the stat explore node, right? Or was that because of
Oh,
form-based?
right, yeah. So you cannot generate those graphs within the Stat Explorer, but after that you can still do that.
So what I'm trying to understand is it because somehow that churn data has been fundamentally changed into something else?
No, it's not. It's about this node. It's about this node particularly.
Okay.
So if you try to do graphs within this node, you will have access to a different sets of information,
Yeah.
but not the raw data set, but not the churn data set. But in every other node, let's say transform variables, I go to the results, I can do plot again, and I can see the same set of, oh, I guess not. Yeah. So let me revise. Not always you can see the original data set. It's about some of the nodes. So to be sure that you can generate the graphs that you want, this is the best place to be. The Graph Explorer is to customize the graphs. Yeah.
So I guess my question was, could we have put that graph explore node after that stat explore?
Of course you can.
And when we try to plot it, do we get the same graph or do we then get a different set of graphs?
In most cases, you get the same graph. Yeah. If you customize all the other settings the same. Yeah. Sometimes there's a random sampling going on, right? So that doesn't guarantee you get the same sample, right? If you don't tweak the settings, right? Other questions? So everybody's quite tired, so let's go home. Yeah. Any other questions? Let me know. Feel free to stay. And I like you. I want you to stay. But if you need to go home, go ahead.
Dr. Ma, will you record the first part of the class that whenever the projector went down? I don't think it was.
Yeah. No, it is.
Okay.
It's recorded.
Okay.
Yeah, it's I forgot to turn off at one point, so in the break, so it kind of recorded everything. But yeah. All right. Have a good night, though. Yeah. Yeah. Let me turn this on.